Before solving the questions, first visit our concept builder section. So in this exercise, we have studied about rotational symmetry. Rotational symmetry is a concept which is very much known to you. Every object in this world can be rotated around a certain fixed point. Just take this example. This is an arrow. If we take this as fixed point, then this can be rotated in two directions. Either this side, this is called clockwise because clock moves in this direction, therefore it is clockwise, and the other rotation is anti-clockwise. So when we rotate any object, then the concept of a rotational symmetry comes. So if you rotate an object and its new position is very similar to its previous one, then we say that the object is symmetrical when rotated, or has certain order of rotational symmetry. So that is basic about rotational symmetry. When we study about rotational symmetry, we have certain things to follow. Number first, there must be a certain point through which that object is rotated. Second is how much degrees we are rotating the object. For example, in this case, we are rotating it 90 degrees. Then again, 90 degrees, that will become 180 degrees, and so on. And the another term that we have studied in this exercise is order of rotational symmetry. That after rotating it, how many times it appears to be like its original state. And the important thing, while rotation, there is no change in shape and size, there is just a positional change. So let's study more about order of rotational symmetry. So here, this figure denotes order of rotational symmetry as 1. That means while rotating this object from this fixed position, that is, it will rotate like this. We are rotating every object clockwise. There is only single time that it appears like this. So let's first rotate it 90 degrees. So when you rotate it, it will be like this. Then we check whether this image appears to be like this. Well, no, it is not. Then we again rotate it by 90 degrees, that is total 180 degrees from this position. Therefore, this figure is obtained. Well, it is again not similar to the original figure. Then we again rotate it with 90 degrees, that is 270 degrees. That is, initially it was here, now we are moving it like this with clockwise direction. Well, it doesn't look like this. Then we again last time rotate it 90 degrees, that is complete rotation has been formed, and you know it very well from previous standard that complete rotation denotes 360 degrees. And yes, now we can see that this object looks alike the original one. Therefore, with the green, we have shown that this object has a rotational symmetry of 1. Now, if you visualize that every object in this world will have at minimum 1 order of rotational symmetry. Now let's see order of rotational symmetry of 2. Suppose this is a rectangle, this is the original shape, and we are putting this red dot just to show you that it is rotating, and this blue dot means we are rotating from this fixed position. So if you rotate, if you put force from this side, then it will be like this. This is very similar like if you have paper, a rectangular paper, and you put pin here and you rotate it, then this paper will rotate and new position will be like this. Now we compare it to the original. Whether it looks like this? Well, no. Therefore, it is represented with red. Then we again turn it with 90 degrees. Well, the angle has not to be always 90 degrees. We are just rotating it. And whenever we see the new position as the initial one, we mark it with 1 order and so on. Then we again rotate it and we see, yes, it looks like original shape. Therefore, this is first order of symmetry. Then again, we rotate it with 90 degrees. That is total 270 degrees from initial position. Well, they are not similar images. Then we again rotate it last time. Then we see, yes, it is similar to the original shape. So it is another order. So these two green moves means 1, 1, that is 2 order of rotational symmetry. Now let's study a figure having order of rotational symmetry as 3. So this is the initial position. This is just to demonstrate you that it is rotating, that this position is now this position when we rotate it. So it is first rotation because it appears to the original image. Then we again rotate it, that is this point is now here. We are rotating it clockwise. Then again it appears like first image. Therefore, it is the second move or second order of symmetry. Now, we have one more option to rotate it. We rotate it and we get back the initial position. Therefore, this again matches the first figure. Therefore, there are three moves which makes the figure appear like original image. Therefore, we have order of rotational symmetry in case of equilateral triangle is 3. This is the equilateral triangle having 3 sides equal. Now we have a figure which contains rotational symmetry of 4. So initially we have figure like this. This is our reference point. When we rotate it 90 degrees, we get this. Again, this figure appears like this, therefore one order of symmetry. Now we have a chance to rotate it with another 90 degrees, and this point comes here. Again, this image appears like initial one, therefore we have 2 order of symmetry. Again, we can rotate it with 90 degrees, then this point will come here, and that is 3rd order of symmetry. And lastly, we can rotate it and we get this back, and that also appears to the initial image. Therefore, this image has 4 order of rotational symmetry. So by this we can conclude that a regular image will have as that much of orders as the number of symmetrical arms it has. Well, it is not always true, but it is true for regular polygons. This you will study in later sections as well. So this is a bit about rotational symmetry. With this, let's solve our questions. Question first, which of the following figures have rotational symmetry of order more than 1 from A to F? Well, so far we have studied that any object in this world will have order of symmetry as 1. Even you as a person have order of symmetry 1, because we can rotate you clockwise or anti-clockwise, and after a 360 rotation you will be at your original position. Therefore, you have an order of symmetry as 1. But in this question we have to tell those figures which have rotational symmetry of order more than 1, that is 2, 3 and so on. So first figure is this. So this is the first figure, and we have put this red dot for our reference. So when we rotate it 90 degrees, we get this, that is this point comes here, and we can see this image appears to be like this. So it has 1 order of symmetry so far. Again, we rotate it with 90 degrees clockwise. Now this point comes here. So this is 2nd order of symmetry, because this image appears like this. So we are only following 2 steps. That is, first of all, we are rotating. You can rotate an image in any direction, either clockwise or anti-clockwise, because most of our objects follows clockwise direction, so we follow clockwise. And the next step is you just compare the new position of image with your original image, whether they appear same. Now we have another chance to rotate it with 90 degrees. We get this image, and this image is very similar to the original image. Then again, one more chance. So we rotate it and we get this back, and this back is very similar to the original image. Therefore, total 4 order of symmetries are there. So the question was just asking that which images have order of symmetry more than 1, but we have also demonstrated their actual movements. So that is, A has order of symmetry more than 1. Now let's see for this equilateral triangle. Well, we have already shown this in our concept builder section. Let's visit again. This point moves to this, therefore 1. This point moves to this, therefore 2nd, and this point moves to 3rd, and all these images are very much same to the first one. So therefore 1, 2 and 3. This 3rd represents like the initial one. This was the initial one. So therefore there are 3 order symmetries. Well, this is the only figure in this question which do not have order of symmetry more than 1. It has only 1. That is, it is just like you. That is, when you rotate it 90 degrees, it will be something like this, which is totally different. But there is one case when it is very similar to this, but there is a trick. That is, when you rotate it 180 degrees, it is like this. But see, now these are towards left hand side. These square boxes, here it is right hand side. So these figures don't match. So this figure has only 1 symmetry. That is, when now we will rotate it 90 degrees, then we will be able to get this figure. So only 1 symmetry. If you have read anywhere that any object which does not coincide with its previous image is said to have order of symmetry at 0, that is wrong. Always in this world, any object will have at least order of symmetry as 1. Here it is a big H written, and these crosses just means that these objects has to be rotated, keeping this point as fixed. That is, you nail it. You put a pin and then you rotate it. That's why these crosses are present in every question. That is just for reference. Initially it is like this, and we have put this for a reference. That is, we have to show that it is rotating. So when we rotate it with 180 degrees, we get this object, and it is very similar to this one. Therefore, so far order of symmetry is 1. Then we again rotate it like this, that is clockwise, and we get back the original figure, and which is very similar to the actual image. Therefore, order of symmetry is 2. For D, well, we will show it as cross because it doesn't have the required criteria. That is, order of symmetry is not more than 1. Therefore, this is a cross. Now this circle, again, this is our initial figure. Let's put point here for reference. When we move it with this angle, then this point comes here. It appears to be like first one. Therefore, order of symmetry so far is 1. We again rotate it with this angle. It appears to be like 120 because 12 3s are 36. Rotation around a point makes 360 degree. Therefore, one angle will be 120. When we move it further 120 degrees, we get this, and it is very similar to the first one. Therefore, second order of symmetry follows so far. And there is one more chance because initially the point was here. When we rotate it once 120 degrees, we get this, and this is very similar to original one. Therefore, 1, 2, 3 order of symmetries are there. So generally, without actually drawing it, we can know the order of symmetry by watching the pattern. So this pattern is repeated 3 times, 1, 2, 3, and it appears to be regular. That is, this shape is very similar to these shapes and equal in sizes because it's a circle. Therefore, generally, the number of shapes we have equals order of symmetry. For example, here, without actually moving towards representation, it appears it has 4 patterns, 1, 2, 3, 4. Therefore, 4 order of symmetries will be there. But just to confirm, let's visit the actual rotation. So initially we have this, we have put red for our reference. You can also put it in order to demonstrate to your teacher that we are rotating it. So when you rotate 90 degrees, this is 90 degrees, or just when you rotate it, there comes a time when this image appears to be like this one. So far, one rotation of symmetry, and we again move it 90 degrees, then this image appears to be like initial one. So this is second order of symmetry so far. Again, this dot can be moved to this point when we rotate it 90 degrees. So third rotation of symmetry. Again, there is one rotation possible, again 90 degrees. We get it back as our original one, and since it matches our initial one, therefore it is fourth order of symmetry. So in this way, and by now you must have got the idea that how to find order of rotational symmetry. So that is your first. Question second, give the order of rotational symmetry for each figure. This question is again very similar to the previous one. The only difference is that it is asking us to give the order of rotational symmetry for each figure. So we have shown it graphically. So initially this is our image for A part. We put a red point as a reference that we are rotating it. Nothing new in this. So when you rotate it, now we will not tell you about angles. We are just rotating it, and whenever we see that the image that we have rotated appears to be like first one, we mark as order 1, and likewise we do it until we make a 360 round. So this is the whole concept behind rotational symmetry. You just rotate the object whenever you find that image appears to be like original one, that is order 1, and you do the process till you reach the complete rotation. So we rotated it. So this is the initial point. We are rotating it, and we come to this position when this red dot comes here, and we see this appears to be like our initial image. So it is order 1 so far, yet we haven't completed our complete rotation. So we again move it, and we come back to our original position and see that yes, it is appearing like the initial one. Well, you don't have to see for the last move because it is already understood that you are going to exact image when you rotate 360 degrees. That's why every object in this world will have a rotational symmetry at least once. Therefore, order 1 follows for every object. So you have 2 rotational symmetry for A part. Second, well, this is a little bit tricky. Here, although this image appears to be like that this angle is equal to every angle because you're given 80 degrees here, what will be this angle? Obviously 100 degrees because angle on a straight line is 180 degrees. So it is 80, so 180 minus 80 is 100. So this angle is not equal to this angle. So when you rotate it, like we are rotating it clockwise. So we have demonstrated 2 reference points in this case. So this is our initial image, this one only, and we are rotating it, and we come to this position. Although it appears to be like first one, but it is not the first one. Here are the most of the chances that you will mark this as order 1. It is not order 1 because this angle, it is vertically opposite angles. This angle is 100 degrees, whereas in original image it is 80 degrees. So this is the move, but it will not be counted. So now you understood why we don't count it. Then we continue rotate it and we come to this position. Well, yes, this was 80 degrees because vertically opposite. Again, this is 80 degrees vertically opposite, and these are 100, these are 100. So this is the move where we will write order 1 because we are getting exact shape as of our original image. Again, we have a chance to move, we come to this position like this. Again, it is not our order. Therefore, we write order. Order means in proper decorum, that is in proper orientation. Therefore, order term came in order of symmetry. So this is not the order. Again, you rotate it, you get image like original. So it is understood. Last one is always understood. So we have order 2 in this case. So not order 4, that is 1, 2, 3, 4 or 5. It is order 2 because these don't match the criteria. By now, you have got the idea about the concept of order of rotational symmetry. See, let's put reference here, then we rotate it, then this is here, again appearing like original image, order 1. Rotate it, appearing like original image, order 2. Rotate it, we have come to original image, so order 3. That we have already done in previous question. This, again, we have told in concept builder, the same question has been repeated. So let's put point here, rotate it once, point here, it appears like original one, rotate it, then this point comes to this point because we are rotating 90 degrees, appears like this, order 2, again rotate it, appears like this one, order 3, again rotating, last one is understood, it will have addition of 1 order, therefore order 4. D has order 4. Here, this is our image, let's put reference here, rotate it 90 degrees or just rotate it, forget about angles. You get this image, therefore order 1, rotate it again, this point comes here, appears like initial one, this is order 2, rotate it, this point comes here, appears like initial one, order 3, and the last one is understood. You will get back the position, therefore order 4. That's E. Now it's a pentagon, 1, 2, 3, 4, 5, and it is regular. That is, all these sides are equal. We have to consider that. So you know, every angle is 72 degrees, therefore we are rotating it 72 degrees. Just for your reference, or when you're solving this, you just have to rotate it and see the image that you get after rotation, whether it appears like our initial one. So let's put reference here. This is very similar to this one. We rotate it once, that is 72 degrees for your reference. This point comes here. Well, yes, it appears like this, therefore order 1. Again rotate it, it's 72 degrees. Yes, it is similar to this one, order 2. Again 72 degrees, we get this position, third order, because it is very similar to the initial one. Again rotate it, this point comes here. Yes, it is very similar to the original, therefore order 4. And the last one is understood, we get that position back, therefore order 5 for regular pentagon. By now you must get the idea that for regular heptagon you will have 6 order of symmetry, octagon 8 symmetries. Here we have a star. Let's put our reference here, move it once, this point comes here, appears like initial one, yes, order 1. This point has to come here now, did so, appears like initial, yes, order 2. Move it, this point will come here, order 3, because similar. Rotate it clockwise again, this will come here, order 4, because looks like initial one. Again rotating it clockwise, it comes here, order 5. Again last image like initial one, so order 6, because it is very similar to initial one. So we see 1, 2, 3, 4, 5, 6. 6 regular patterns, therefore 6 orders of rotational symmetry. Here these are legs, 3 legs of an object. So let's put this red dot on one of the toe and rotate it, this time anti-clockwise. This dot comes here because we are rotating it anti-clockwise. So appears like initial one, yes, therefore order 1. Rotate it another time anti-clockwise, this point comes here, appears like initial one, yes, therefore order 2. Again rotate it, where we get its position very similar to the initial one that we have started, so it appears like original image, well yes, therefore order 3. So this is very interesting question. That is, questions of rotational symmetry are very fascinating. You must practice more questions in order to get grasp of this concept. So with this, second is completed.